Okay, here it is, example 6. So here's the question. Find the solution to the differential equation. That means find y, right? The solution is y, the function that satisfies the differential equation, given this initial condition. Okay, so I have L instead of y, right? L is the y. So let's figure out what the independent variable is. Okay, by looking here, I can see t is like the x, right? So what's this k? What's the k? K must be a constant. So be careful that you're just carrying it along. Just another letter in there. I know, it's just annoying, but just want to make sure you're keeping it straight. Okay, so separating the variables. So multiply by dt, and then I want to divide by L squared. So now I have it, right? dl, L squared, dt. Remember, dl and dt must stay in the numerator. K could be on either side because k is just a constant. I'm just going to leave k right here. So let's just rewrite this left-hand side as L to the negative 2. And this side here, oh, right, you know how to do the integral of ln. This is where you use parts. You let u equal ln of t. Sorry, and then dv equal dt. du is 1 over t, v is equal to t. So I'm going to put that k on the outside, so you get u v minus the integral, oops, put the d there, v du. So you get k times t ln of t minus the integral of 1 dt. So that's just t, so there it is. So this is the left-hand side, the right-hand side. And the antiderivative of L to the negative 2 is L to the negative 1 over negative 1. So again, I'm going to suggest you write this negative exponent, put it in the denominator. So now right here, this is the easiest place to solve for the c. So let's go put in the t is 1 and the L is negative 1. L is negative 1, gives me a positive 1 on this side. Putting in t is 1. ln of 1 I know is 0, so that's gone. Negative k times 1 plus c. So your c is going to have a k inside of it, right? The k is just a constant. That's okay. So that's my c. So 1 plus k. So 1 plus k gets put in there for the c. And then remember, we're solving for the L. So I'm just going to cross multiply by the L, and then I'm going to put all of this in the denominator, right? Multiply by the L and divide by all of that. And that's as simple and as pretty as it gets. All right, example 7. Find the solution, find y to the differential equation, derivative here with the equal sign, with the initial condition, meaning here's the information to solve for the c. All right, so again, write y prime as dy over dx. Let's multiply by dx, keep the dy here, and then I'm going to divide by y and multiply by y plus 1, and keep the sign on the right-hand side. All right, so this fraction here, take the time to separate it. If you have addition or subtraction in the numerator, then you can separate the fraction. Y over y plus 1 over y. Okay, so now I have two things to integrate on the left-hand side. Integral of 1 with dy is y, and you know that's ln of absolute value of y, and this gives me negative cosine. Okay, so now I'm going to write here, oh, and plus the c, put the c in right away. Now I'm going to use my initial condition. So this says use x equals 0 and y equals 1, right? Make sure you get that correct in the right order. So now I'm going to put in y equal 1. ln of 1 I know is 0, so I get 1 on the left-hand side. Cosine of 0 I know is 1 with the negative sign, and so c turns out to be 2. So I put the c is 2 in there, and then you take a moment to look at this and you say, yeah, there's no way to solve for y, so this is the solution, right? It's impossible to solve for y, so y is given implicitly. Remember that from first semester.